Now when you solve any problem in this chapter, I would like you to keep the chart that I gave you with the addition rule and the multiplication rules. So let's read the first question, problem 5. Suppose the probability of a randomly chosen American being blood type A is 45% or 0.45. Suppose that's given to us. So let's write that down. So as you're reading the question, it's a good idea to write down your probabilities. So probability of A is 0.45. And where do I get that from? By reading the question. The event A is being blood type A. Now, although this is not given, this is an immediate consequence of the given probability. What is the probability that a randomly chosen American is not blood type A? That would be 1 minus 0.45, which is 0.55. Just write it down. You may or may not need the probability, but it's good to have it ready. So writing it down in mathematical notation is important. Okay, for any event, use uppercase letters like A, B, and something that reminds you of that particular event. So blood type A reminds me of blood type A. That's why I've used the letter A. Now, the next step is to find out the event for which we're trying to figure out the probability. So what is the probability that the next two people, note that there are two people who walk in through this door, both have blood type A. So the event is two people both have blood type A. So I'm going to write it down in a way that I clearly understand which formula to use for this particular event. So this is how I've written down the event. So I want you to look at this. So probability of A, so the first person is A and the second person is A. And that's the same as saying both of the people are blood type A. So I'm writing it down this way so I can use the right formula. So in a large population, from one outcome to another, that is selecting a random person with blood type A, the two events are always independent of each other. So according to the rule, AND translates to multiplication, and it's simple multiplication of probabilities if the two events, selecting a person with blood type A in the first round and selecting a person with blood type A in the second round, are independent of each other. So we simply multiply the two probabilities based on the formula, and that gives us the final answer. Just use your calculator to figure that out. Now let's read the next question. In the state of Florida, 75% of all patients first diagnosed with spinal injury are males. So we're looking at the population of all people who are diagnosed with spinal injuries. So that is our population. What is the probability that in this population a random person is male? That would be 75% or 0.75. The immediate consequence of that also needs to be written down. The probability that in that population of spinal injuries, the probability that the person with a spinal injury is female is 25%, because it's 1 minus the probability of male. So that would be 1 minus 0.75, and that's 0.25. So now we have two probabilities. One is probability that a spinal injury is a male is 0.75, and probability that the person with spinal injury is female is 0.25. Now we are going to use these probabilities as necessary based on the event for which we're calculating the probabilities. Let's read the first question. What is the probability that a patient, so one patient, diagnosed with spinal cord injury in Florida is female? So we already have that done, and that would be 1 minus the probability that the patient diagnosed with spinal injury is male, which is 1 minus 0.75, which is 0.25. So part B says, what is the probability that the next two patients diagnosed with spinal cord injury in Florida, the first will be a male and the second will be female? So there are two patients now, not just one. The first is male and then we have female. Notice that the order here is very specific. So what we're trying to find out, always write it down as a in mathematical notation. So this is the probability we're trying to figure out. What is the probability that the first is male, notice the order, and the second is female? So the word and goes with the multiplication rule, and we've discussed that from one trial to another, the events are independent, so we simply multiply the two probabilities. The probability of the first event times the probability of the second event. We have the probabilities, we just multiply it, use our calculator, and that gives us the final answer. The important thing is to be able to write down your probability event carefully and then use the correct formula based on the chart that I have given you. Now let's look at problem C. What is the probability? So we need to calculate a probability, so that's P of the next two patients. So we again have two patients diagnosed with spinal injury in Florida. One will be male and one will be female. Note here that there is no specific order. It doesn't say first male then female, so we cannot assume that. It says one is male and one is female, which gives us two possibilities. It could be male first and then female, or female first and then male. So if the order is not specified, we need to make sure that we consider both the cases, MF, male first then female, and the second case, which means or, there's another possibility, female first and then male. In both these cases, there is one male and one female. Without a specific order, we need to consider both the cases. So that's something to remember. So probability of male and female, the word or goes with addition. So we've used the addition rule for the two disjoint events, plus the probability of female first and then male. The word and goes with the multiplication rule. We've seen this before. So its probability of M and F changes to probability of M times the probability of F, plus probability of F and M is probability of F first times the probability of M. Now all we have to do is substitute the numbers. We already know probability of M is 0.75 and the probability of F is 0.25. So plugging in the numbers into the formula, we get 0.375. Just use the calculator. Now this question is a little different. Of the next 5 patients, now we have 5 patients diagnosed with spinal injury, what is the probability that at least one is female? Now first let's think about what it means when I say at least one is female out of the 5. So let's look at the various things that can happen. So we're looking at 5 injuries. First is female, the next 4 are males. In this case, the first is male, the second is female, and the next 3 are males. Again, first 2 males, then 1 female, 2 males. Do you see that we have a long list of possibilities where there's exactly 1 female? But now since it says at least 1 female, it's possible that there are 2 females in the 5 patients who are diagnosed with spinal injury. So what if there were 2 females? Look at the various possibilities. We have 2 females, then 3 males. Female, male, female, male, male. So that's another case in which you have exactly 2 females. That's another case where you have exactly 2 females. There's this long list, and it goes on and on. So the next thing we might have to consider is, what if there are exactly 3 females? Then you come up with another long list. So how do you calculate the probability of an event that has multiple outcomes? It almost seems like a tedious task to list all the outcomes, then calculate all the probabilities, then add all the probabilities. The minute you're thinking of this long process, you're probably asking yourself, is there an easier way out? And the answer is, yes, there is. Think about, what is the opposite of at least one of the 5 patients being female? What is the opposite of at least one of the 5 patients is female? The opposite of that event is none of the, so the opposite is, the word none is used. So the opposite of that is none of the 5 patients is female. So probability of an event, at least one of the 5 patients is female, is equal to 1 minus the probability of the opposite, which means 1 minus the probability that none are females. When I say none of the 5 are females, that is the same as saying all 5 are males. So that would be 1 minus the probability of all 5 patients being male. So that's male first, and then male again, and then male again, male, male. So it's male, 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 5 times. So the word between the males is and, so that gives rise to the multiplication rule here, and that's what we've used. It's 1 minus probability that the first is male, and, which means multiplied by probability that the second is male, the third is male, the fourth is male, and the fifth is male. So we are multiplying the probability of male repeatedly 5 times. So that would be probability of male times the probability of male times the probability of male, and so on. So it's probability of male to the 5th power. So notice that's what we've done here, and that would be 0.75 to the 5th. Use your calculator to get 0.7627. So do you see that this is the easy way out instead of listing these multiple possibilities and then adding all those possibilities?